Okay, so if you weren't here last day when we talked about this, this question for a differential equation is fairly standard, so you should know how to do these ones fairly cold. Like, you should be able to get into it, spend 10 minutes on it, and feel confident with your answer. So can anybody give me some suggestions to get this started that might help speed things up for us? Yeah. Oh yeah, you're way ahead of us though. We're just looking at the slope field right now. Yeah.
Why can I, once y is equal to 1 is equal to 0?
Right. So when y equals 1, the whole thing will equal 0. So that's a quick way that I can get some slopes here. Now, I don't. Yeah, it wasn't drawn in the picture here because it shouldn't be defined at 0. So I'll just erase those dots. Okay. And then, did anybody else come up with another shortcut, or do we need to just start calculating? Yeah. Yeah, it's pretty. Those are good choices to do because when x is 1 and negative 1, then all you're doing is looking at the value for y minus 1. So along this vertical line here, y minus 1 is going to be negative 1. Then this is going to be at 2 minus 1 is positive 1. Same thing will happen at negative 1 here because you square it, you get back to positive 1. So you have the same values, negative 1 and positive 1. And then the last one we have to do is at x equals 2, and I don't think we have a shortcut there, so we'll just go ahead and write them out. And remember, the shortcuts aren't necessary. If you're not good at picking them up, that's fine. It just means you're going to have to spend a little more time doing it, and that's okay. So here I'm going to have negative 1 over 4. Here I'm going to have 0, which we already know. And this will be 1 over 4. All right, so negative a quarter, I'll guess looks like this. Positive a quarter will look, I don't know, about like that. Okay, so slope field done. Part B says, find a particular solution with an initial condition that f of 2 equals 0. Okay, so here's the differential equation again. And if I rearrange this, I'm going to have dy over y minus 1 is dx over x squared. And that's what I'm going to integrate. So on the left side, I'm going to have natural log of y minus 1. And when I integrate this, it's going to be power rule. It's going to be negative 1 over x and a constant. Now, I had a discussion after class about when you could solve for the constant. I believe I made a mistake when I told you that you could do it here. You won't be able to use that here. You may run into a problem with your constant. What we should do is, I'll explain why it'll make sense. We should do it at the very end because this is not the function here. That is not f of x, so if I'm putting my condition of f of 2 equals 0 into it, it may not turn out to be right because that's not the function that I'm started with. The actual function I started with is this one, where I go e to the negative 1 over x plus c equals y minus 1. And I can rearrange it. This is the function that I would have started with. So this is the one that I'm going to solve for the constant in. Okay? That is a function of x. So at this point, you should be comfortable with this step. Hopefully I don't need to go into an explanation. It's just using the exponent laws. And then I know that when x equals 2, y equals 0. So 0 is equal to c e to the negative 1/2 plus 1. And if I rearrange that, let's see here. I'm just going to lose it for a second here and there. I'll bring it up. That means I've got negative 1 is c root e. So that means I can move this over. So c is the negative of root e. So this was where I had started. That's the particular solution that I should be answering with. That'll be, let's see here, e to the negative 1 over x minus root e. And the last part of the question says, for the particular solution, describe the limit as x goes to infinity. So what is, for part C, the limit as x goes to infinity of, e to the negative 1 over x minus root e. All right, so what do you think? How can we simplify this as x goes to infinity? How can we write that? Oops. What do you think? Okay, yeah, you're right. I'm just going to go a little slower than you had it. So there's going to be a 0 there because when x goes to infinity, this piece here goes to 0. So then that's going to become e to the negative root e. Okay, so I'll put this one